Greetings of the day, dear students. In this video, we are going to discuss about the voltage and current relation in star network. We will see its vector diagram, right? And also, we will discuss the relationship between the voltage and current in the given star network. And also, we will discuss its summary and we will do one example on this topic, right? Uh, if you observe, let me consider a star network having voltage sources, three phase voltage source VRN, VYN and VBN. VRN indicates the phase voltage R phase, VYN Y phase, VBN indicates the phase voltage. Now IR, IY, IB indicates the phase currents. Observe here this IR, IY and IB. Now with respect to this neutral point, with respect to this neutral point and line, the voltage is VRN. Similarly, the voltage between two lines between R and Y, denoted with letter VRY, is the line voltage, and VYB, RY, YB and VBR, these three indicates the line voltages. VRY, VYB and VBR indicates the line voltages between two lines, right? Now our focus is what would be the relation between the line voltage and phase voltage, and also between the line current and phase current. If you observe, in a balanced three phase system, the magnitude of the voltages will be same, right? And they will differ by an angle 120 degrees. How do we understand that? For example, the Rn, the phase R phase is having magnitude Vp at an angle 0, then the Y phase voltage will also have the same magnitude, but it will be lagging the phase voltage R by 120 degrees. Similarly, Vbn with respect to Yn 120, but with respect to the Rn 120 plus 120, 240 degrees, right? So therefore, Vrn equal to Vp at an angle 0, Vyn equal to Vp at an angle minus 120, Vbn equal to Vp phase voltage at an angle minus 240, right? Here Rn, Yn, Bn are which voltages? Sorry, V, Ry, Yb, Br are line voltages. Now, this is what we have drawn here. This is Vrn at an angle 0. Now Vyn, this is Vyn at an angle minus 120 degrees with respect to the Rn, right? Clockwise direction rotated, clockwise. This side rotated clockwise. After Rn, Vbn. Observe between these phase voltages, the angle is 120 degrees. The three phases are 120 degrees apart from each other. 360 degrees, the total angle is 360 among the three phases divided by 3, so we will get 120 degrees phase difference will be there between each phase, right? Now Vry will be how much? It is nothing but simply Vrn plus Vny. Now Vny is nothing but minus Vyn. Therefore, Vrn is equal to how much? Vrn minus Vyn. It is the vector sum Vry equal to Vrn plus Vny. I repeat again, Rn indicates the phase voltage, R phase. Similarly, Vyn also indicates the phase voltage, Y phase. But Vry indicates the voltage between these two lines. And this is Vrn. Vrn. Right? Yeah. Now, later that similarly VYB also. VYB can be written as VYN plus VNB. Now VNB is nothing but minus VBN, right? And VBR equal to VBN plus VNR. It is also equal to VBN minus VRN. Now if you observe, just now for all the phases the magnitude is same, but the angle difference is 120 degrees. Angle difference is 120 degrees. In this diagram, minus 120 degrees. If you are rotating in the clockwise direction, minus 120 degrees is also same as if you rotate in the anti-clockwise direction, minus 120 is also same as plus 240 degrees. This is important. Clear? Both are one and same. For example, if somewhere if you see some x or some 10 at an angle minus 120, its meaning is it is also same as 10 at an angle. Instead of minus 120, you rotate in the clockwise direction up to that point. Then what is that angle? 240. Out of 360, 120 is completed. What is the remaining angle? 240. So minus 120 is also same as 240 degrees. Similarly, 10 at an angle minus 240 degrees. For example, minus 240 is there. Then it is also same as 10 at an angle plus 120 degrees. That is the reason why here we have written RYB sequence. Here actually we should write minus 240. VP at an angle. This is also same as VP at an angle minus 240. But minus 240 degrees is also same as plus 120 degrees. Observe this diagram. Right? Yeah. Now this is in the R at an angle theta format. R at an angle theta. This is in the polar form. If you write it in the rectangular form, what is the value of x? X plus some iy. X plus some iy. What is the value of x? R cos theta plus I times R sin theta, because x equal to R cos theta, y equal to R sin theta. That is what we have done here. Express the polar form into the rectangular form. Now VP at an angle 0 is equal to the VP bracket of 1 plus J0. VP at an angle minus 120 is equal to, express it in the rectangular form. The R we can take it out common. Cos minus 120 degrees plus J times sin 120 degrees. Cos minus 120 degrees equals to minus 0.5, and sine minus 120 degrees is equal to minus 0.866. That is the reason why when we convert this polar into rectangle, we will get this equation. Similarly, phase voltage at an angle 120, polar form, write it in the rectangular form. Once we have expressed the polar forms into the rectangular form, now let me focus on the Ry. Ry is nothing but Vrn is a vector sum, Vrn minus Vyn, right? But what about Rn? Observe, substitute its rectangular value. Similarly for Yn, let me substitute its rectangular value. If you add those two, you will get Vp bracket of 1.5 plus J 0.866. Again convert this rectangular form into polar form. Now we will get root 3 times V phase at an angle 30 degrees. This is very very important. Root 3 at an angle, root 3 V phase at an angle 30 degrees. How do we understand that? That means the magnitude Vry, nothing but the which voltage? Between R and Y, line voltages, between two lines, line voltage is equal to root 3 times the phase voltage. Very very important. So Vry we can represent with letter line voltage. VL is equal to root 3 times V phase. It is something like, for example, if the line voltage is in between two lines, if you are having 400 volts, then what will be the phase voltage? 400 by root 3. Like that we have to understand. In star connection, all this is with respect to the star. In between two lines, if the voltage is 400, then the phase voltage will be line value divided by root 3 magnitude wise. Now observe, dear students, this is very important. The angle wise, the line voltage is, observe here in this diagram. From this phasor diagram, first we will write the VRN, VYN and VBN, each one at an angle 120 degrees. In the next step, it's quite opposite, anti-phase. Anti-phase, we will represent minus VRN with dotted line. Similarly for YN, we represent minus VN with dotted line. And for VBN, minus VBN, it's quite opposite, 180 degrees, anti-phase, right? Minus VBN. Now we will draw a parallel line to the V minus VYN. This is drawn. Now this VRN plus of minus VYN. If we join these two, this is nothing but the VRY. This is which voltage? VRY is the line voltage. Now if you observe, this line voltage and the angle between this line voltage and phase voltage is how much? 30 degrees. Out of these two, which voltage is leading? The line voltage is leading the phase voltage by how much angle? 30 degrees. Very, very important. Magnitude wise, we are clear. Magnitude wise, the line voltage or the phase voltage will be VL by root 3. So indirectly the line voltage magnitude is root 3 times the phase voltage. But angle wise, VRY is 30 degrees leading the phase voltage in star connected 3-phase balanced source. Clear? Now with respect to the current flowing in this phase, in the R phase, is same as the current flowing in the line. These two are in series. So what happens in series connection? What will be same? Observe, whatever the current is flowing in this phase, in this R phase, is also flowing in the line. These two are in series. Therefore, the line current is same as phase current. In which connection? The line current is same as the phase current in star network. But what about voltage? The phase voltage will be equals to the VL by root 3. But whereas with respect to the current, what is the condition? Phase current and line current both are same. These two derivations are very, very important. Clear? Right. Now, observe one more interesting point you can observe here. Just like as if you have drawn VYN, you can also draw VRY. We can also plot RY, after RY, YB, this part, and BR, this part, RY. Observe again these line voltages are 120 degrees apart from each other. Already the phase voltages between each phase voltage, the angle is 120, and again the angle between two lines is also 120. Observe, between this is the angle, this between angle between VRY and VYB will be 120 degrees. But the important point is angle between line voltage and phase voltage is 30 degrees. Line current is same as phase current, right? These are all the important summary points with respect to the star connected network. And one more important basic, minus 120 degrees is also same as plus 240 degrees. Plus 240 degrees. 360 minus, you can do that. Out of 360, you subtract this 120. Right? Like that we have to understand. Now what is the summary in star connection? Dear students, please observe, IP, P indicates phase value. IP means phase value. IP is the phase value, phase current. IL indicates the line current, line current. So phase current is same as line current. Phase voltage equal to VL by root 3. Magnitude wise, line voltages are 30 degrees ahead of phase voltage. How do you understand that? If for example, if this is the R phase, VR, now your VRN will be like this. VRY will be like this. So the VRY is 30 degrees ahead of the phase voltage. Like that we have to understand. Line voltages are 30 degrees ahead of phase voltages. Phase voltages are 1 degrees apart from each other, and also at the same time line voltages are also 120 degrees apart from each other. Now whatever the angle existing between the phase voltage and phase current, for example if this is the R phase VR, and if the phase line current is IR, now if the angle difference between the phase voltage and phase current if it is phi, now what will be the angle between the uh, line voltages and line currents? It will be 30 plus or minus 5. It will be 30 plus or minus 5. Don't bother about the line voltage angle between the line voltages and line currents, right? The angle between phase voltage and phase current is phi, right? And that angle will be positive if the power factor is lagging, and that it will be negative if the power factor is leading. Clear? Right. Now one more interesting point: if a neutral wire is present in this star connected network, if you are also having the neutral wire, right? Now the current in this neutral wire will be equal to IR plus IY plus IB, that will be exactly equal to 0 if the system is perfectly balanced. If the system is perfectly balanced, no current should flow through the neutral wire. But practically it is not that much easy to exactly balance the system. Balanced system means in all the phases, for example VR, VY, VB, all the phases must have the same magnitude. For example, all should have the same magnitude same in the sense, for example it should be same, some 220 volts, but angle wise they must differ by 120 degrees, 0 minus 120 degrees, and this one should be magnitude wise must be same, minus 240 degrees. This is called perfectly balanced system. When we will call it as a system is balanced, magnitude must be same, angle must be 120 degrees, difference must be there. Angle difference must be 120. If it is a voltage source, right? If the system is balanced, IR plus IB equals to 0. And the current in the neutral wire will not be equal to 0 if it is unbalanced system, right? Yeah. Now let me do an example. A 400 volt voltage is applied. This is in between two lines. A 400 volts voltage is applied to a star connected balanced load having resistor 100 ohms in each phase. Find line currents and phase voltages and power drawn. In this star network, dear students, please observe the voltage is given 400 volts. That 400 volts is in between the two lines, between any two lines. Here I considered A, B, C. Between A and B, 400 volts at an angle 0, or 400 volts is the magnitude given. Between B and C, between C and A, the magnitude is how much? The line voltage is given 400 volt. Which connection? Star connection. Resistor in each phase RA, RB, RC, each one is of magnitude 100 ohms. So we have drawn a star network with resistors RA, RB, RC, each one of value 100 ohm, 100 ohm, 100 ohm. Now current flowing in this line is same as the current flowing in this phase. So in star connection, the line current is same as phase current. Now in order to calculate the current flowing in this line, if you know the phase voltage means exactly the voltage between this line A and this neutral wire. This neutral wire. If you know this voltage, phase voltage, then easily we can calculate current. But in star connection, what will be the magnitude of phase voltage? Vp equal to phase voltage equal to VL line voltage by root 3 magnitude wise. Clear? Yeah. Now VL is already given 400 by root 3. Therefore the phase voltage is 230.9 volts. Now what will be the phase current IA? IA equal to phase voltage divided by resistance 230.9 divided by 100. So we will get 2.309 amps. As the system is balanced and all the phases are having same impedance, now the current magnitude also will be same. IB will be how much? VP divided by RP. Now what is the phase voltage? 230.9. What is the resistance in the B phase? RB 100. 230.9 divided by 100. So 2.309. IC VP divided by RC 230.9 divided by 100 2.309 amps. Therefore IA, IB, IC, the magnitude of currents are 2.309 amps. Now what will be the power? 3 phase power 3 times V phase I phase. Clear? 3 times V phase I phase cos phi or if you write, dear students, please remember this formula, very important. If I say, for example, somewhere if you have seen 3 Vi cos phi root 3 Vi cos phi, then if you have used 3, then this voltage and current values must be phase values, very important. If you have used root 3, both are correct only. Both are correct only. If you have used root 3, then this voltage and current must be line values, very important. You just be familiar with 3 V phase I phase cos phi. If the power is asked in a 3-phase circuit, power P, active power P equals to 3 times V phase I phase sorry, 3 times V phase I phase cos phi. Right? Now in star connection, the phase current is same as line current. But what about phase voltage? VL by root 3. If you substitute that in the place of V phase, you have written VL by root 3 into I phase is same as IL. So 3 by root 3 into root 3 by root 3. Root 3 into root 3. 3 get cancelled. 3 times root 3 VL IL cos phi. Very important. Both the formulas are correct only. You can use either 3 times V phase I phase cos phi or root 3 times VL IL cos phi. Right. Now what could be the angle between the voltage and current? Because observe, the load is resistive from the previous basics, right? If current I is flowing, V is the voltage across resistor, then both the voltage and current will be in phase in resistor. The angle between those two will be 0, right? So sin 0 0, cos 0 is 1, cos phi 1. Therefore root 3 into VL is already given 400 volts into IL line current is same as phase current. We have calculated 2.309. It is equal to 1599.72 watt. It is also same as 1.599 kilowatt. Very important, dear students. In this entire discussion in star network, please remember phase current is same as line current. Phase voltage is equal to line voltage by root 3 magnitude wise. And the power formula is 3 times V phase I phase cos phi or root 3 VL IL cos phi. L means line values. If you are having a star network like this, if this is R phase, if this is Y phase, and this is B phase, and if you are having a neutral, and between R and this neutral point, this value is called the phase value. This is simply VR value. But if you measure between this R line and Y line, then this value is called line value. Simple, very simple. In some textbooks, simply they will write VR. If you are interested, you can also write VRN between the line R and neutral. The difference between VRN and VRY is VRN is the phase voltage and VRY is the line voltage. Current wise, there won't be difference. Same current flows in the phase and also in the line. Clear? So this is what all about the voltage and current relation in the star network. This diagram is also important, dear students. Okay, thank you.